Hey, geometry students. Last week we practiced learning how to find sine, cosine, and tangent if we are given the sides of a right triangle. Well, today we're going to see how we can use those ratios, sine, cosine, and tangent, to help us find missing sides and angles on right triangles. So here we go. The first thing we'll see is we're usually given a right triangle. We'll call this one ABC. Okay, so for this first example, we're going to find a missing side. So usually then they'll give you some more information about the triangle. Like they might tell us that angle A is 32 degrees. And maybe they tell us that side AB is 17 centimeters. And we are wanting to find this missing side AC right here. Okay, so what we want to do is, with respect to angle A, since that's the angle that we know, we want to label these two sides as our opposite, adjacent, hypotenuse kind of thing. So if I'm looking at this angle A, 32 degrees, this is the adjacent side, and this is the opposite side, and this is the hypotenuse. Okay, so the two that I'm interested in here, the one that I know and the one that's missing, are the adjacent and the hypotenuse. So right here, it's going to be helpful to us to remember what sine, cosine, and tangent ratios are. So if we remember SO, CA, TOA, SO tells me that sine is opposite over hypotenuse. CA tells me that cosine is adjacent over hypotenuse. And then TOA tells me that tangent is opposite over adjacent. So I want to pick the one to use that goes with the two that I'm interested in right over here on our triangle. In this case, adjacent and hypotenuse tells me that I should be using cosine, since cosine is adjacent over hypotenuse. So here's how I'm going to set up my problem. I'm going to take my chosen trig function, cosine, and it's going to be cosine of angle A, and angle A is 32 degrees. So cosine, parentheses, 32 degrees, equals the adjacent side over the hypotenuse. So x over 17. Okay, so now what I want to do is solve this equation for x. And remember, when I can type cosine of 32 into a calculator, and it will give me a number. So on this one, all I have to do to get x by itself, since it's x divided by 17, all I need to do is multiply by 17 on both sides. So my 17s cancel out. And then into a calculator, I can type 17 times cosine of 32. So I'm going to do that really quick. Grab my calculator. 17 times cosine 32, enter. And we get 14.42. Boom. And then we throw the calculator on the ground. So in celebration, 14.42 equals x. So that's my missing side, 14.42 centimeters right here. And that's all there is to it. So that's finding a missing side. And this particular case was a little bit easier because the side that we're missing is on the top of the ratio. So I'm going to show one more version of doing this kind of problem, solving for a missing side, but where the value you're missing is on the bottom of the ratio. So let's try one like that. I'll leave this same triangle because why not? But this time we're going to have different values. So this time we're going to say angle B is 51 degrees. And let's say that this side right here, AC, is 15 inches. And we're missing side AB. Okay, so we want to solve for side AB, and this time we're doing everything from the perspective of angle B because that's the angle that I have. Just a note, if you know all of the angles, which in this case it would be very easy to figure out the other angle because they add to 180 degrees, all three of them. But if you know all the angles, then you can do your trig ratio with respect to either angle. Doesn't really matter. But in this case, since I'm given 51 degrees and I don't want to do extra work, I'm just going to do it with respect to angle B. Okay, so here's angle B. And according to angle B, this is my opposite side, since it's across from it. And then since this is across from the hypotenuse, this is my, since this is across from the right angle, it is the hypotenuse. This would be the adjacent side, but I don't know anything about it, so I'm not really going to do anything with it. Okay, so we have the opposite and the hypotenuse that we're worrying about here. And since sine is opposite over hypotenuse, that tells me that I want to use the sine ratio. So sine of angle B, the angle always goes inside, so 51 degrees, equals 15 over x, since it's opposite over hypotenuse. Okay, so for this one, since the x is on the bottom, there's a couple different ways you can think of it. The first way you could think of it is I'm going to multiply by x on both sides to get rid of the fraction. So now we have x sine of 51 equals 15. And then I can divide on both sides by sine of 51. So that those cancel and we're just left with x over here. And then I can type this into a calculator. That's one way you can think of it. So then I would type 15 divided by sine 51, enter. And we would get 19.30. So that tells me that my hypotenuse here is 19.3 inches. The other way that you can think of it is if you have x on the bottom, you can just kind of automatically know to go, okay, I'm taking the top number divided by the sine of 51, or whatever your trig function is over here. So you could memorize that method, or you could just remember how solving equations works. Multiply by x on both sides, divide by sine on both sides, and then you're good to go. Okay, so that's how you would do it if you have the thing that you're missing in the denominator of your ratio. So that's pretty much whatever could be thrown at you with solving for missing sides. Now, solving for missing angles, if you remember our lesson from last week on using inverses of sine, cosine, and tangent, you're going to find this next part really easy. If you don't remember that, then I would go back and watch that video first, but we will have a quick refresher of what inverse, sine, cosine, and tangent were. So now we're going to solve for missing angles. Okay. And I'll leave that up there. So in order to solve for a missing angle on a right triangle, well, first you need a right triangle. The second thing you need is at least two of the sides. Okay. So they will ask you for a particular angle. I'm going to go with, we'll just solve for angle B this time. So I don't know what angle B is. And they're going to give you two of the side lengths. So maybe this is 7, and this side is 9. And we want to find angle B. Okay, so we have at least two side lengths, so we're good to go. And we want to start this one out the same way that we started the last kind of problem we were solving for missing sides. So I want to go, okay, labeling things with respect to angle B, since angle B is the one I'm trying to figure out. This is my opposite side, so 7 is my opposite. Angle C is the right angle, and this side's across from that, so that's the hypotenuse. And then 9 must be my adjacent side, since it's next to it, but it's not the hypotenuse. Okay, so the two that I know are the adjacent and the opposite. So now I'm going to pick a trig function that has to do with opposite and adjacent. And the only one that works for that is tangent, because tangent is opposite over adjacent. So now I'm going to set this up just like we were doing problems last week. If I was looking for tangent of B, it would be opposite over adjacent, so 7 over 9. So I'm going to set up this equation, and then so that I can get angle B by itself, we're going to use inverse tangent, because that's going to get rid of my tangent here. So I'm going to go tangent inverse. So it looked like tangent to the negative first. It undoes tangent. So I'm going to do that to both sides. So tangent inverse of tangent of B equals tangent inverse of 7/9. So then my tangent inverse cancels out my tangent, and we're just left over here with angle B. And then this is something that I can type into a calculator. And remember, it's usually a secondary function. So if you're using like a regular calculator like this, you'll probably have to hit second and then tangent. If you're using Desmos, it's listed under functions. So I'm going to type second tangent, 7 divided by 9, enter. And it tells me that angle B is going to be 37.87 degrees. So there's angle B, 37.87 degrees. If you wanted to find angle A also, well, now that I know what angle B is, and now that I know also that C is 90 degrees, we always knew that, then I can just go, all three angles must add to 180. So you could subtract both of these from 180, or knowing that it's a right triangle, you could also use that these two angles must add to 90. So you could just subtract 37.87 from 90. Either way, but that would get you angle A as well. Okay, so hopefully this was helpful. I'll post some other examples that go with it. So if you need to see it again, you can. And then if you have any questions, send me an email, comment below, come to office hours, any of the above. Have a wonderful day.